In the last video, we saw how to calculate the slope using the definition of the derivative, or the definition of the slope for a specific function. So let's just do some more examples for different types of functions. So once again, let's remember that the slope function is synonymous with the derivative function. So from now on we'll just call it the derivative function. So the derivative function. So the definition is, and we're going to call it f prime. So the slope function of the derivative function is, once again, the limit as h goes to 0, not x, but as h goes to 0, of f of x plus h minus f of x over h. So let's start off with actually with a linear function. So let's just take a linear function like, say, 2x plus 1. Okay. So we should expect that we know what is the slope of this function right away. Right off the bat, we can tell that the slope is 2. So our derivative function should work. So let's just test. Let's just see if we get 2. So once again, let's do the definition of a derivative. So I'm going to do that. So f prime is going to be the limit as h goes to 0, f of x plus h minus f of x over h. And so this is equal to the limit as h goes to 0. Now, since f of x is 2x plus 1, x plus h should be 2 times x plus h plus 1. This is your f of x plus h minus 2x plus 1 all over h. 0, so I'm just going to expand the top. It's going to be, the numerator, 2h plus 1 minus 2x minus 1 all over h. So you should see that before we do anything, some terms in the numerator actually cancel out. The 2x cancels out, the 1's cancel out, and all we're left with is 2h. So whenever you're doing these derivative functions using the definition of the limit, as we're doing right now, and you expand and you start canceling terms out, you should always observe the only terms that you should be left with should contain an h. If you're not, like for example in this case, we're left with 2h. If, however, there is a term that does not have h, then you know you've done something wrong, so just check your work again. So let's just move a little further down, and so the limit as h goes to 0, so I have 2h over h. I can see once again that the h's will cancel out, and I need to cancel out the h, remember, because we can't have the denominator set to 0 or it's undefined. And so what I'm left with is equal to 2, which is what we expected in the first place. Now let's try it with a square root function. So let's try, let me just move a little further up. Okay, so the second type of question we're going to try is, let's say f of x is equal to x plus 1 square rooted, and I want to find the slope. So I want the slope, or the derivative, at x equals 0. So just to give you an idea of what this graph looks like, this graph is actually starts at -1. It's a square root function. It goes like that. Oops, maybe not the best. It goes like that. Okay. And what we're interested in is finding. So this is where x equals 0, and what we're interested in is finding the slope right there. Okay. So so once again, we go back to our limit definition. So it's f of x plus h minus f of x over h. Okay, limit h goes to 0. So this is going to be x plus h. So all you're doing is you're taking the x plus h and subbing it into the x. So plus 1, we got the square root there, minus the original function, which is x plus 1 over h. So if you recall, the way to find the limit when we have square roots is to multiply it with its conjugate. So what you're going to do effectively is multiply by the number 1. And if you multiply by an expression that has the same numerator and denominator, you're basically multiplying by 1. And what we're going to multiply it by is its conjugate, which is almost the same as the numerator, except the operator in between switches. So instead of a minus, we're going to have plus, so it's x plus 1. And the bottom, the denominator, is also going to be the same because, remember, we're just trying to multiply by 1. If we don't, then it's a completely different equation. So let me go back to black. So what we're going to do next is, so what I like to do in this case is never keep everything in factored form in the denominator. So don't multiply the h into that, just leave everything in factored form. Plus x plus 1, square root there. Okay, and one of the reasons why we multiply by the conjugate is because we will get a difference of squares. So in other words, it'll be x plus h plus 1 squared minus x plus 1 squared. So I'm just going to move this up a bit, and this is now equal to the limit as h. Remember, we have to still keep writing the limit as h goes to 0 until we apply the limit itself. So this is going to be x plus h plus 1, because the square root and the square cancel out, minus x plus 1 over this whole thing, x plus h plus 1. The denominator does not change at all. So I'm just going to expand the top, and I get x plus h plus 1 minus x minus 1 all over h, x plus h plus 1 square rooted plus x plus 1 square rooted. And what you'll notice, remember what I said last time, some terms need to cancel out. And all you should be left with is the terms that have an h in them. They could have an x and h in them, but they need to have an h in them. So we can see those terms cancel out, and what we're left with is just the h on top. And so what this is equal to is limit as h goes to 0, h over h, x plus h plus 1, h plus x plus 1. The h's will cancel out. And so what we're left with is equal to, and so now we can apply the limit. So it's over x plus 0 plus 1 plus x plus 1. So x plus 0 plus 1 is the same thing as x plus 1. So really what we're left with is 2 of the same, right? And remember the original, so that is our derivative function. So this is our derivative function. But remember, we were interested in finding the derivative at a specific point. And what was that point again? That point was 0. We were interested in finding it 0. So all we have to do now is go back down to the function and just plug in 0 for x. So what that means is the slope, f prime, or the slope at 0 is simply 1 over, all you have to do is just plug in 0 there. So all I did was I plugged in 0 for x, so I get 1 over 2 square root of 1, which is equal to half. So what that means is the slope is equal to a half when x is equal to 0. So in other words, if I just go back to that little diagram that I drew before, the slope of this red line, the slope is simply equal to half at that point. The slope of that red line is equal to half.